Hello, I'm Carper Sorensen.
And I'm Nicholas Thompson. We're from Fort Myers, Florida, and we assess the viability to use the subatomic particle, the muon, as a solar flare detector through a correlational study.
For those who aren't aware, solar flares are brief eruptions of intense, high-energy radiation from the sun's surface. These events emit massive amounts of electromagnetic radiation capable of knocking out power grids and GPS systems.
After contacting the educational liaison at Fermilabs, we were able to access the raw data compiled by their muon detectors on site. These detectors work in the following way. First, particles pass through a gaseous tracking device that notice each particle in the area. Then an electromagnetic and a hadronic calorimeter eliminate particles with massive charge and large masses. Finally, particles pass through an identification chamber in which Chekhov's radiation is utilized to notice the speed at which these particles are traveling, and finally their momentum. We then compiled this data into a flux study and cross-referenced the trends against the NASA Solar Event Archive. We identified several more trends in the process.
The first was that on an average day, around 13 to 14 muons impact a square meter per minute. Conversely, within a matter of seconds, the impact rate spikes to rates of 3,000 or even 6,000 in a stepwise function that clearly delineates heightened activity periods. Although we originally believed solar flares would occur at the climaxes of increased muon activity levels, what we found was different.
These heightened activity periods always preceded a solar event but didn't necessarily occur during one, making it a possible additive to solar event prediction systems currently in place.
This advance could possibly increase the period of awareness before an event occurs by up to 12 days, and when coupled with solar satellites, could reduce the amount of energy necessary to detect them.
Hopefully, as technology increases in the future, new detection systems coupled with technology to protect our GPS satellite systems could make for a possible detection and protection system from these solar flares.